A great group with us this morning, and welcome everyone to the John Marshall Everglades Internship graduation. We're thrilled to see all of your faces virtually here and glad you could join us. So this morning, I want to welcome Ms. Nancy Marshall to start us off.
All right, thank you, thank you. Well, good morning, and what a great morning it is that we celebrate the 2021 John Marshall Summer Intern Program. It is my honor to welcome you to the 18th annual John Marshall Summer Intern Program. And I want to begin with a huge thank you to the many individuals who've embraced this program since its conception by John Marshall in 2002. You all know who you are. You've been part of this village, and we are just so thrilled to continue this wonderful program. And Catherine, Michael, and Maxwell, today you are joining the prestigious group of 79 John Marshall alumni who will help us continue this incredible journey to restore the Everglades and educate others to become environmental stewards. I'd like to share a short quote from Marjorie Stoneman Douglas, author of River of the Grass. She said, "Although my phrase, the river of grass, first awakened people to the notion that the Everglades is a river, it was Art Marshall who filled in the pieces." Marjorie Stoneman encouraged Art Marshall to build upon his dreams of educating undergraduate and graduate students in the important work of restoring and preserving the natural habitat of the Everglades. To that extent, many years ago, Marjorie offered Art her nonprofit status and $1,500 seed money. And in those days, that was probably a large gift. And following in his uncle's footsteps, John Marshall was just so committed to fulfilling the mission of Art Marshall and brought the summer intern program to fruition in 2002 with just 2 students. And at that time, they worked on a PowerPoint. And think of how many years ago that was. We needed a PowerPoint. So today, fast forward, let's get this program underway.
Thank you, Nancy. Next up, we have Jennifer and Eric to talk about the Everglades Foundation and our education programs.
Sarah, thank you. Let me also welcome you all this morning to this special program. It's a delight to be with not only Nancy Marshall here this morning, but also to the 3 Marshall interns who are joining a legacy of tremendous work within the Everglades ecosystem. And the future is bright for Michael, Catherine, and Maxwell, and we're delighted that we're again with them here this morning. I want to just follow on Nancy's opening remarks there to make the connection that she mentioned, Marjorie Stoneman Douglas, and the relationship that Marjorie Stoneman Douglas had with Arthur Marshall, and the impact that the 2 of them had on the pursuit of Everglades restoration, having that passed on to John Marshall as the dutiful nephew of Art Marshall, a patriot, a veteran of our military, our U.S. military, a conservationist to the core in John Marshall. And he and Nancy, together as a partnership, really pursued what we are after even today. And it was the work of John and Nancy and the Art Marshall Foundation that really spearheaded much of the great progress at the beginning of this effort to restore and protect America's Everglades. I want to thank Nancy for her continued work. She's a tremendous member of the Everglades Foundation Board of Directors. She continues each and every day with her passion to ensure that this national treasure, the water supply now for 9 million South Floridians, the economic engine of Florida, built around tourism and boating and fishing and clean water, is preserved for generations to come. So Nancy, on behalf of our chairman, Carlos de la Cruz, our entire staff at the Everglades Foundation, we want to thank you for your continued fight to restore and protect the Everglades. We're delighted here this morning as we, as Nancy laid out the history of this program, to have another graduation, adding 3 more to this illustrious alumni group. But we're also excited this year to be formalizing the partnership that we've created now with Florida International University. FIU is a tremendous leader in the fight for Everglades restoration, for true science-based solutions to the issues that are facing our waterways, our Everglades, our wetlands, as well as the issues impacted by climate change. I want to thank FIU for stepping up to join us. We're joined this morning by Dr. Rita Teutonic and her expertise within FIU. But this is a exciting new partnership for the Marshall Intern Program, and to have Michael, Catherine, and Maxwell be the first 3 who experienced this vibrant new partnership. We're delighted for that as well. As we gather, there is great momentum around the Everglades, whether it's the rewriting of the Lake Okeechobee manual, the operating manual, whether it's the efforts in Washington to secure increased funding for Everglades infrastructure, and the continued progress. I'll be tomorrow with a number of folks celebrating the completion of the Kissimmee River, which started under Governor Bob Martinez in 1987. I know John Marshall and Art Marshall and Nancy were very committed to ensuring that the Kissimmee River be restored. And after now almost 40 years, tomorrow, the 29th of July, 2021, we're going to put a flag in the ground knowing that the Kissimmee River is fully restored. And what a tremendous example that restoration works. And the Kissimmee, that natural meandering river of the Kissimmee, is back. And it's a testament to folks like Nancy Marshall, John Marshall, Art Marshall, Marjorie Stoneman Douglas, Mary Barley, and many, many others who have said, we're not going to give up. We're not going to stop. And it's an exciting day tomorrow. It's an exciting day this morning, again, to highlight our 3 interns, the Marshall interns. It's a delight to be with you all this morning. Thank you very much. Jennifer, I'll pass it on to you.
Thank you, Eric. Welcome and good morning. We are excited to be here, although not in person. We have embraced this virtual atmosphere, and we're really excited to share with you what our interns have been doing over the last 10 weeks. And they are excited to also present their research to you. But to just step back for a minute and reflect on the growth of the educational programs within the Everglades Foundation, the John Marshall Everglades Internship is a strategic part of these educational programs. And borrowing the words from our Vice President of Development, cradle to career. And so from kindergarten for family events that we've been hosting to talk about the Everglades at the dinner table, to talk about our environment restoration, the work that we have been doing, and to expand these educational programs to assure that we have a generation, multiple generations, investing both in the classroom, in their homes, in their graduate studies, and in their careers. We really help to move not just the John Marshall Everglades Internship Program, but the legacy of that program. And our K through 12 students, as you know, enjoy the Everglades Literacy Program that really educates these young Floridians about the ecological and economic value of this ecosystem and inspire them to protect it for many years to come. The Everglades Foundation continues our education program and John Marshall Everglades Summer Intern Program this year, providing 10 weeks of immersion experience through science research, policy, education, and communications. Through our Everglades Scholarship Program, we mentor, train, and partner with graduate students and future STEM leaders. And lastly, but not least, our 4 Everglades Technical Partnership grants that target scientists conducting research aimed at advancing our knowledge through Everglades physical, chemical, and biological processes. This year was an exciting year to partner with Florida Atlantic University. We continue the components of the John Marshall Everglades Internship that are so important to our interns in our community through research, really deep field experiences, but expanded those professional development opportunities. And so these 3 interns not only had 10 weeks to dig into these big scientific research projects, but they had to attend professional developments, Everglades 101, education for the Everglades. They had to work with Rita and her team and what it feels like to work and be in this high level academic community. They've now have 10 weeks and we expanded up by 2 weeks. They have a full stipend and full room and board. They get a deeper understanding of these issues through actual hands-on research and have really expanded their network, interviewing, and resume building opportunities. In addition, we've expanded their support system and presentation opportunities. So not only do they have the Everglades Foundation board and staff, but they have a system at Florida International Universities with professors and mentors within that system. And this year, we'll celebrate 3 interns, 2 from Florida International University and 1 from Gorton College. I would like to introduce Rita Tutonicchio. She has been instrumental. She is our partner at the university and has really helped us to envision with Nancy Marshall how this looks, how this partnership looks, and how we advance it, improve this legacy, deepen this legacy, and broaden our reach. Rita, I'm going to hand it off to you.
Oh, thank you so much, Jennifer and Dr. Eichenberg. I'm really delighted to be here, and I just want to add my welcome, and also on behalf of Florida International University and the Institute of Environment, just thank the Everglades and Nancy Marshall for this opportunity to partner and for your support of these students. It's been really amazing opportunity for us, and we're looking forward to further advancing this. So I just wanted to also thank Steve Davis, who has also helped us vision this when we first started talking about the partnership. So thank you again for your assistance with that too, Steve. So I just wanted to say a little bit about our research experience for undergraduate site program and what that is, and then what we're thinking about going forward into the future. So these research experience for undergrad sites are funded by the National Science Foundation. There's a network of around 800 sites across the country, only 5 in Florida related to biology. So we're delighted that we are one of those 5. And we bring in students, as Jennifer said, in the summer to engage them in research and field trips and get them excited about new opportunities and new ecosystems that they might never have seen in their prior experience, and also provide them professional skills for numbers of STEM careers. And what has been so great about our partnership with the Everglades Foundation is we're finding that students really want to make a difference, right? They really want to be out there on the front lines. They really want to impact policy and restore these precious environments. So it's a natural partnership between FIU, which is very solutions oriented, and the Everglades Foundation to give them this opportunity to really see how can you impact these areas and how can you actually make a difference. So we are delighted that we could add 3 more students to our cohort with your support. They were able this summer to be part of a group of 19 interns that we had from across the whole country. So what's wonderful about this partnership is also now they're part of this bigger network. And so we were able to expose all these students to the Everglades. And finally, the weather cooperated and they all were able to go out yesterday, Sunday actually, to get out in airboats because it's been too dry. So I was so excited that they were able to fit that opportunity, and for everyone, not only our interns. So we really are excited about the support. We're in the process of writing our renewal for the research experience site to the National Science Foundation. So integral to that renewal will be our partnership. And we're talking about maybe even adding a DC component where we actually take some of the students to DC for a week to really see how, you know, the sausage is made and be on the Hill and talk to congressional staffers and really have the learning about how they could actually be impacting policy going forward. So that's a really exciting opportunity. And I really am thankful again for this opportunity to partner with you. And we look forward to working together more in the future. And I'm really want to just also thank the mentors who supported our undergrads throughout the summer. It's been a big team effort. So I know John Komnowski is on the line. So thank you, John, and the other mentors as well. We are going to have our big research symposium tomorrow. So if anyone has time, I know Jennifer is going to come, where all 19 are going to present. So it'll be at Florida International University at the ballroom. So that'll be an exciting day. It's always bittersweet to see them leave, but we're really excited that they have this opportunity. And hopefully many of them will come back and work again. A lot of them are excited to come back and help Florida and help the South Florida with our ecosystem restoration. So we look forward to those as well. So thank you again, and look forward to continuing our partnership.
Thank you, Rita. It's been an incredible, very quick 10 weeks. So we'll get right into our three wonderful interns. We are here to celebrate our 2021 John Marshall Everglades interns. 10 weeks has gone by very quickly for them. They have been in it through field trips and research and in professional developments and presentations and networking. And we're proud of the work they've been able to accomplish in those 10 weeks. First, we will introduce Mike Bobola. He has been studying the correlation between total mercury levels found in juvenile bull sharks, tissues, and their conditions. Next, Catherine Holting. She has been studying invertebrate communities with the Florida Coastal Everglades Long-Term Ecological Research Program. This is the first survey of invertebrates at this site and will inform how different salinity, nutrients, litter quality impact invertebrates in the Everglades. And last but not least, Maxwell Tax, whose research focuses on analyzing the relationship between trophic levels and secretions of fish nutrients. So while they're deep in research and lab activities, they're also out there exploring the Everglades ecosystems, learning the science and policy behind it, how to communicate it at different levels. And so we will start with Catherine. Catherine, I'm going to hand it off to you.
Thank you, Jenny, and thank you all for being here today. My name is Catherine Holting, and this summer, along with PhD student Kenny Anderson and Dr. John Kamenowski, I looked at interactions between invertebrate communities, water chemistry, and organic matter processing in the Everglades. And you can go ahead and move on to the next slide. Oh, and one over. Yeah. So I first wanted to take a moment to introduce myself more. I'm from Severna Park, Maryland, and I grew up on the Severn River and the Chesapeake Bay. I'm currently a senior biology major at Gordon College in Massachusetts, and I first became interested in conservation my freshman year when I took an animal biology course. Currently, I'm interested in how land use changes on a regional scale impact ecological processes, especially in context of habitat fragmentation. So now throughout the summer, we went on a number of field trips with the RAU program to visit South Florida's major ecosystems. We went kayaking through mangrove forests, out on a boat on Biscayne Bay. We visited Lila to learn about experimental Everglades research, and my personal favorite, the Wakota-Hatchie wetlands, to see wood storks and other wading birds. And just this past Sunday, we were able to go out on an airboat to see the Everglades. So as important and fun as these field trips were, they were also good for putting the research we are doing into perspective, especially for me who had never seen these ecosystems before. So as I mentioned, this summer I was looking at invertebrates and organic matter. And I first wanted to take a moment to talk about why we should all care about organic matter processing. And when I say organic matter, I'm talking about dead plant material and its breakdown. Wetlands are major carbon storehouses. They sequester CO2 from the atmosphere and store it in the form of plant biomass and soil. And as a huge wetlands landscape, the Everglades is one of these carbon storehouses. So understanding how carbon moves through the system will help us understand how the Everglades will respond to climate change. Decomposing leaf litter also helps to vertically build up soil. So again, knowing what impacts litter breakdown rates will help us understand how resilient coastal ecosystems will be to sea level rise. So in this research, we are mainly interested in asking two questions. First, we wanted to know what the relative contributions are of top-down and bottom-up pathways on organic matter processing. Top-down pathways are invertebrates impacting litter breakdown rates, mainly by shredding leaf litter. And bottom-up pathways are environmental characteristics that could alter litter breakdown. We were focused on hydroperiod, salinity, and phosphorus. Both these top-down and bottom-up pathways could be altering litter breakdown rates. And so we want to know to what extent each of these are occurring. Next, we also wanted to understand how these environmental characteristics and litter quality impact these invertebrate communities themselves. There's still a need for more research on invertebrate communities in the Everglades, so we're looking to add to that research by looking at what shapes these communities. So to understand and answer these questions, we looked at 6 of the long-term research sites in the Everglades. 3 of our sites were in Shark River Slough and 3 were in Taylor Slough. Shark River Slough, which you can see in the middle there on the map, is a highly productive environment with peat soil, while Taylor Slough is less productive with marsh soil. Our sites were positioned so that we had marsh, ecotone, and mangrove sites so that we could look along this gradient of salinity and phosphorus. So last December, the Kamenowski lab collected 4 litter types: sawgrass, which is a low quality litter, and spikerush, mangrove, and seagrass, which are high quality. Each of these litter types was collected from its respective environment and then dried, weighed, and deployed to freshwater, ecotone, mangrove, and marine sites. So for example, sawgrass was put out at all 4 sites and so on. And you can go ahead and click to the next slide. So after these litter bags had sat in the environment for 4 months, they were collected and the invertebrates inside of them were preserved. And this is where I came in this summer, going through these invertebrates, identifying them to the family level and measuring them. So across 6 sites in 80 litter bags, there was a total of over 2,500 invertebrates in 56 taxa. Looking at the density graph on the next slide, you can see that density varied across our sites. SRS2, which is one of our freshwater sites in Shark River Slough, had a much higher density than any other site. And comparing this to our Taylor Slough sites, this could be because Shark River Slough is a more productive environment and so can support a higher number of individuals. SRS4 and SRS6 there at the bottom are still in Shark River Slough, but they experience daily tidal stress, which could limit the number of invertebrates that can survive this stress, resulting in this really low density that we see there. Moving to the richness plot, we see a different trend. Our Taylor Slough sites have a higher richness than our Shark River Slough sites, meaning that they have more families of invertebrates. And this higher richness at Taylor Slough could be because Taylor Slough periodically dries down, which could limit the amount of fish predation in Taylor Slough and open up new ecological niches for invertebrate predators. Taylor Slough also has more benthic periphyton, which could be providing refuge for our invertebrates and resulting in a higher richness. We also see in this graph that richness decreases in both sloughs as we move towards marine sites, which could be because of a number of changes in nutrients and water chemistry at these sites. Moving on to litter breakdown rates, you can see from this graph that there are some differences across sites and litter types, but what's interesting is that there's no relationship between these litter breakdown rates and the density of invertebrates found at each site. If you remember, SRS2 had almost 3 times the number of invertebrates as TS2, and yet their litter breakdown rates are relatively similar, which suggests that our invertebrates aren't playing a huge role in litter breakdown, so we're not seeing that top-down effect on litter. This could also be because there is a lack of shredder invertebrates in our litter bags, which are invertebrates that forage by tearing apart litter. These would be the invertebrates that we would expect to have the greatest impact on litter breakdown. So because of their low numbers in our litter bags, it makes sense that we're not seeing a huge top-down effect on litter. And lastly, we can also look more broadly at community composition by looking at an ordination diagram. In this diagram, the distance between space represents how similar those litter bags were in their invertebrate communities. So the closer 2 points are together, the more similar their invertebrates are. And what I want to focus on here is that the clusters of sites can be explained by water chemistry. These 3 sites that are circled are clumped together, meaning that they have similar invertebrate communities. And all 3 of these sites also have similar salinity and phosphorus levels. Invertebrates are responding to subsidies and stresses like nutrients and salinity. And as we get more data in the future, it'll be interesting to see if there are any clear trends within specific families. So as far as the future, there are still more invertebrates to be identified. And we're also looking at getting specific nutrient ratios for each litter bag. We already know generally which litter types have higher nutrient ratios, But this way we'll be able to compare the invertebrates in each litter bag to the nutrient ratios of that litter. And lastly, as we get more invertebrate data from all 3 time points, we'll be able to do a more detailed analysis looking at how phosphorus and salinity impact these communities. So moving to the next slide, these invertebrates seem to be responding mainly to environmental characteristics. And understanding these interactions will help us understand how these communities will change with water level and salinity, which is especially important in light of sea level rise and saltwater intrusion. Invertebrates play a key role in food webs. They transfer nutrients from detritus to higher trophic levels, which helps support predators like wading birds in the Everglades. As I said earlier, there's still a need for more invertebrate research in the Everglades. So understanding these communities is not only going to provide us with more insight into invertebrates, but also into food webs and carbon cycling, which are both important for assessing the health and productivity of the Everglades. Moving on to the next slide. So just to conclude, this research for me has really emphasized the impact of water chemistry on the environment and reinforced the importance of our coastal ecosystems. Even if you might not think of carbon cycling or invertebrates as having a direct impact on your daily life, these are areas that are important for continuing to explore because they're important for understanding this environment that we rely on for our well-being. For me personally, this was my first time visiting the Everglades, and having the opportunity to contribute towards our understanding of this amazing area was incredible. The Everglades Foundation internship was important for linking the research I was doing with restoration. And I know the same principle of keeping research in the context of restoration and conservation is something that I can take with me in the future as I move forward. Thank you, and are there any questions?
Great job, Catherine. It's pretty impressive how much you have learned and how much you have explored in just 10 weeks. Anybody have any questions for Catherine?
I do. Hi, Catherine. That was a great presentation. I really enjoyed it, and I know that this is an area of need really for understanding that base of the food web out in the Everglades, as well as you described, the stability of those organic matter deposits that we have out in the Everglades. I'm wondering if you've thought about kind of the organisms that you can collect in those litter bags versus the other things that might be out there, particularly as you get further into the mangroves. I'm thinking crabs in particular. How would you sort of adapt this study or conduct additional observations to sort of get a better snapshot of the detritivore community that exists at some of these sites?
Yeah, that's a really good question. And it gets at a good point. We were only using one way to sample the invertebrates in these communities. There are a ton of other ways. And we were excluding the larger invertebrates that couldn't get into these bags. So I think in the future, it'd be interesting to combine a few different types of sampling to get a broader view of these invertebrates. So for example, like we weren't able to get the mangrove crabs that definitely play a role in litter breakdown, but are too large to get to our bags. So I think mainly just combining a few different types of sampling.
And related to that, did you see any amphipods as you got further into the estuary?
So most of our amphipods were in our freshwater sites. There were a few different families that were more at our marine sites, but I'd say like the number of individuals was highest at our freshwater sites.
Great, thank you.
Any other questions for Catherine?
I'd just like to make a comment that Catherine did as much work, if not more, as I did in a summer as a PhD student at the University of Georgia. What you see is what you get. She did an incredible job. Thank you.
And thank you, John, for mentoring. And maybe Catherine can come back for grad school. So finish up that project.
That's right. Congratulations, Catherine, on all your hard work. We're super excited to add you to our 79 John Marshall Everglades interns, carrying that legacy wherever you may go, continuing your research. We're next going to hand it off to Michael. Michael, are you ready?
Yeah, I am.
Wonderful. Welcome.
Well, good morning, everybody. My name is Michael Borboya, and I'm excited to share with you guys my experience with the John Marshall Everglades Internship. You can skip this slide. All right. I'll start off with a little background. I was born and raised in Miami, Florida. I live right next to the Modesto Monique campus of FIU, and you can see it there, squared in the little blue box. I'm studying biology. I'm a senior, and yeah, that's where I live. And as you may notice, I don't exactly live in a jungle. Well, maybe a concrete one. I know quite a few people in my area that haven't even been to the Everglades, despite it being literally minutes away. And even I didn't grasp the incredible amount of biodiversity of the Everglades completely until this internship. The John Marshall internship showed us seagrass beds, where we spotted manatees grazing in the Florida Keys. And we also went out on Florida Bay, where we caught some of the native fauna, like blue crabs and scorpionfish. And it wouldn't be the Everglades without an iconic airboat ride, where we saw alligators and sailed on top of the beautiful river of grass. Along with all the natural wonders that we saw, we also saw some restoration sites, which showed us some of the testing sites and processes utilized for Everglades restoration. And lastly, Tarpon Bay and the Southwestern Everglades estuaries were my favorite, and that's where I conducted my field research. My research was investigating the correlation between mercury and body condition of juvenile bull sharks across nursery areas in the Gulf of Mexico. My mentors were Laura Garcia and Kurt Gastrich, and we worked together in the High House Lab at FIU. As you can see here, mercury is an urgent issue. While it isn't the driver in any of these situations, it's being released during all of these events. Mercury is a naturally occurring chemical element that is released in the burning of fossil fuels, the burning of organic matter, the melting of glaciers, and volcanic eruptions. High levels of mercury are a problem because it affects fish health. It causes neurotoxicity, which inhibits muscular function, as well as oxidative stress, which can cause organ damage, and it also decreases reproductive hormones, which lowers overall fitness. The global mercury cycle starts off with some of the events that I described on the first slide, and once it's released, it evaporates quickly and enters the atmosphere, where it can actually stay there for years, but it eventually gets deposited in either land or water, where it then becomes methylated by bacteria and enters the food chain. And through the process of biomagnification, mercury can accumulate in high levels in apex predators, like the tuna pictured above, or as for my research, in bull sharks. Okay, and one of the big issues with mercury regulation is that places where mercury are released aren't always the places that are affected by it. Here's a chart displaying mercury emissions across the US in 2011. And on the other hand, here's where mercury ends up in the United States. As you can see, it's not the same as the last slide. Trade winds can move the mercury thousands of miles from its point of origin, and the Everglades are a global hotspot for mercury deposition. And to paint a clearer picture, I merged the two diagrams together to show how mercury can be released in large amounts in the northeastern United States, and a majority of it ends up in the southeastern United States. However, the Everglades don't only get mercury from the US. Mercury from around the globe ends up in the Everglades due to global trade winds. And it's, as I said before, the Everglades are a global hotspot for it. And now here are some of the ways that mercury can get into our sharks. The first process is bioaccumulation. This is when sharks ingest organisms that contain mercury. Over time, the mercury builds up, or better yet, it accumulates. And another source is environmental mercury. This is essentially the environmentally available mercury in an ecosystem. And lastly, maternal offloading is when a shark passes on high levels of mercury to its offspring. And the map on the top right corner was released in 2012 in conjunction with a study that tested the levels of mercury in clams. I chose 3 hotspots along the Gulf Coast for test sites. I chose San Antonio Bay and Sabine Lake in Texas, and I chose Tarpon Bay here in South Florida. And all the white dots on the sample site images are sharks that we sampled. So once we caught the sharks, we collected measurements of their length and weight, and we also collected a mussel sample. We then took that mussel sample back to the lab. We weighed it, freeze dried it, and weighed it again. And then we then conducted a mercury analysis using an atomic fluorescence spectrometer, which is pictured in the bottom right-hand corner. And these are the results of our mercury analysis. Tarpon Bay had significantly higher levels of mercury than the other 2 sites, and the other 2 sites weren't significantly different from each other. And here are the weights. San Antonio Bay had significantly higher weights than the other 2 sites, while the other 2 sites were not significantly different from each other. And to further analyze the data, we developed a formula using the trend lines for all the sites to predict the expected amount of mercury or weight of a shark depending on its length. And this is the result. The x-axis of the chart represents the difference in mercury from its expected value, and the y-axis represents the difference in weight from expected value. As you can see, there are 2 trends on this chart, with Sabine Lake and San Antonio Bay taking up the upper left quadrant, where sharks have less mercury and heavier weights, and Tarpon Bay is in the bottom right quadrant, where sharks have more mercury and lower weights. So what can we make of this? Well, the first point I'd like to make out is that San Antonio Bay's heavier sharks can be partly explained by behavior. Tarpon Bay and Sabine Lake sharks have a tendency of staying in freshwater to avoid larger predators like other sharks. However, this comes at the cost of not being able to eat marine fish, which are typically bigger and have more nutrition. And the other point I'd like to make is that even though there's a significant correlation between high levels of mercury and lower weights in sharks, we can't directly attribute mercury as the sole cause for the lower weights. So some of the future steps we could take to directly attribute mercury to harmful effects on sharks is by testing their blood for toxicity stress markers, studying their movement and behavior between estuaries, and also their dietary differences between estuaries. And I will actually be staying with the High House Lab for the next 2 semesters to analyze the blood of juvenile bull sharks for toxicity stress markers. So you might be asking, what are the broader impacts of this study? Well, the most obvious one is that sharks in the Everglades have large amounts of mercury. This can be harmful to anyone who eats bull sharks. Yes, people eat bull sharks. And this also shows that there are large amounts of mercury in the Everglades water system, and also in the animals that inhabit it. One possible solution to this problem is actually being worked on already. Increasing the flow of fresh water from Lake Okeechobee would help in diluting the fresh water, so long as it's clean, mercury-free water that's being added. And this would help alleviate the issues of high levels of mercury in the water. And some of the more personal impacts of this internship was that it gave me additional knowledge and a great respect for the Everglades. And it also helped me cultivate a love for research and inspired me to continue work in the field of ecology. Not to mention, it has really been the summer of a lifetime. So I must thank you all for listening, and thank you, Jennifer, for pressing the slides timely. And if you guys have any questions, please feel free to ask.
Great. Thank you, Michael. It's been wonderful watching your journey and all of the interesting pictures and places you have been. And one question I asked was, when you took the mussel samples, our sharks were not harmed, were they?
Well, we did have to make an incision to take the mussel samples out of the sharks, but we have taken sharks out like a few days after they were caught, and they do heal up extremely fast.
That's what we spoke about earlier. Thanks for sharing that. Any questions for Michael? Comments?
I have a question, Jenny.
Yes, Steve.
Michael, great presentation, and I'm so glad to hear you're going to continue on this project. I've got some experience working in San Antonio Bay as well as the Everglades, but I know that that particular bay has a lot of oysters. And I wonder if there might be some benefit either from a food source perspective, or maybe a benefit and that they filter out particulates that might contain mercury. I just wonder if you all have thought about, factors unique to each of these locations that might contribute to some of those different signals you measured.
Yeah, as I mentioned, there's a lot of factors that go into it. Like, there's no way we can like directly attribute the mercury as affecting the sharks unless we like get them in a tank and feed them mercury. But that is another possible reason as to why they have lower mercury levels. But as for their weight, we believe they weigh a lot more because the food sources in the marine waters are a lot bigger than the freshwater ones.
Any other questions or comments for Michael?
I have a quick question. Michael, great presentation. I may have missed it, and if so, sorry. Did you look at differences in mercury content related to different male-female differences among sharks? Did you account for that? Did I miss that?
Well, we didn't really differentiate between sex and the sharks because it was a fairly normally distributed value. We just tested it overall for all the sharks at the 3 different sites.
Got it. Maybe that's a future study.
Thank you.
That's right. And Michael, you grew up here in Miami-Dade, and you went to high school in Miami-Dade, and I think it's a telling story about the work that we are doing and continue to do to make sure that not only are we supporting undergraduates in their research and other career steps, but also that we are engaging our high school students, right, to make sure that they have the tools and knowledge and understanding so that they can choose also those careers that are going to help and support our environment and our Everglades specifically. So thank you for sharing that. I'll make sure I get to your high school, Michael.
Thank you.
Next, Maxwell Tax. Max, are you ready?
Absolutely.
Perfect. Welcome, Max.
Good morning, all, and thank you for having us. It's a pleasure to be a JM alumni and recipients. So this summer, I studied the effects of handling stress and fasting periods on fish nutrient excretion rates in the Global Change Biology Lab under peer mentor Will Weed and PI Justin Campbell. I'm fortunate to already be attending this university, so I know the ins and outs of it. From a young age, my parents have exposed me to the outdoor beauty of South Florida, but the experience was solidified by the time I graduated high school. I attended Terra Environmental Research Institute and allowed myself to apply many fundamental ideas about environmental science and the world around me. Courses like drone survey classes and AP Environmental Science solidified my knowledge and served as a basis for the person who I am today. About a year ago, I was hired as a naturalist guide for the Florida National Parks Association. And believe me, there's no thrill like showing someone from a landlocked state an alligator for the first time. Learning naturalism has taught me to be a better steward to the environment and has increased my awareness for the implications of what exactly I learned this summer. So what exactly did I research this summer? Fish excretions, endearingly called fish pee by my peer mentor Will, are the nutrient output from fish, occurring both from the digestive tract and the gills. To understand fish excretions, it is important to understand the ecological context of nutrient cycling as a whole. So a past study on fish excretion rates was performed by Matthew R. Wiles in 2009, and it looked at the excretion rates of brook trout. Brook trout, however, have no implications in South Florida ecosystems. They are cold and freshwater species and not even found in the entirety of the southeastern US. Brook trout are also carnivorous, meaning they only eat fish and small invertebrates. Our specimens, however, bay anchovy, are marine planktivores. In this experiment, our central research question was how handling stress and fasting periods impact marine planktivore excretion rates. The sampling site of the fish was performed just feet away from the Global Change Lab in the Biscayne Bay campus of FIU. Pictured on the left, you can see the beach seine nets we used for sampling, along with an example of the planktivore that we frequently caught, a scaled pilchard. Here's me and my fellow undergrad student, Ryan, transferring around fish we had just caught from the beach. We tend to do this due to compatibility issues. Because on the left is a baby barracuda, and they will never reject a free meal. Would you reject a hamburger if it was in your house? I don't think so. After catching the fish, we subject them to 0, 2, and 4-hour fasting treatments. In this photo, you can get a better idea of what exactly our workstation looks like. With so much downtime between fasting and incubation periods, me and my peer mentor and my other friend, undergrad Ryan, had great conversation. We talked extensively about the PhD lifestyle and what dedicating your entire life for 6 years to studying one thing is like, and how that process affects you as a person. We also talked about our ecological adventures in South Florida and beyond, and of course we cracked many nerdy science jokes. Following fasting period treatments, fish are incubated in bags, and water samples were taken at 15, 30, 60, and 90 minutes. Samples are treated with reagents, and the next day were processed with spectrometer. This is just a small fraction of the samples we would gather on a given day, resulting in hours of spectrometer work, a pipette-heavy process. Learning to work a spectrometer and pipette are small technical skills that can be taken for granted. We found no significance of fasting time on fish excretion rates, represented by the box plots you could see in colors. However, we found significance on handling stress rates on fish excretion rates, with 15 and 30 being significant from the rest. 60 and 90 were insignificant. Therefore, an ideal incubation time would be 60 minutes, as 90 is not significant. The Wiles paper that I talked about before used 30 as the only incubation time. Thus, we have refined methods for this work, at least with marine planktivores. A potential reason behind the insignificance of fasting time on planktivorous fish is morphology of the intestines. Planktivores, much like herbivores, have longer guts and engage in more grazing-oriented feeding strategy as opposed to a carnivore that predates less frequently. It's the argument of quantity over quality, nutrient-wise. The vaster implications of this research lay in our bay, and especially current things that have been happening to it. Biscayne Bay is a victim of nutrient runoff, which results in hypoxic conditions and algal blooms. Nutrients from septic tanks leaking and fertilizer from lawns, golf courses, and agriculture are the cause of such. The original flow of the Everglades created one of the most unique and efficient wetland estuary systems in the world before mass water diversion projects for development and agriculture took place. The Everglades provides water in many forms to the 9 million of South Florida. Fertilizer runoff from agriculture is causing algal blooms, which deplete oxygen and kill fish once the water makes its way into our bays. So what's next? By indexing fish excretion rates of resident fish in the Florida Bay area, we could combine said data with fish assemblages. Fish assemblages are essentially residential surveys of what fish live in a certain surveyed area. It allows scientists to understand population dynamics and density of fish. With this data combined, we could better understand the implications of nutrient flow in marine systems impacted by human sources of nutrients, like the Florida Bay. Moving forward, I will continue to seek my degree in sustainability at Florida International University, of course, but I will also be forming my current activism group, Voices of the Wild, into a non-profit club with my colleagues. The club format will largely actually be based on the RU program seminar system, with several guest speakers ranging from naturalists to ecologists to biologists. Our goal is ultimately to inform people about sustainability, biodiversity, and the environment in South Florida, and find the intersectionality between fieldwork, naturalism, sustainability, and nonprofit work. Thank you all. Any questions?
Good job, Max. It was great watching you on this journey and the incredible lab experiences and connecting research in lab, but also with restoration and habitats and organisms. So great work. We're so happy to hear that you enjoyed your time with Florida International University, the Everglades Foundation, and the John Marshall Everglades Internship. Any questions for Max?
Jenny, I got a question that's it's thinking about an extension of this work, and when I think of fish excretion, that obviously in areas where fish are in very high density, it can actually affect water quality to a great degree. And I wonder if in understanding the Everglades and how you get that concentration of prey during the dry season, and you can have little pools with thousands of mosquito fish and other things. I just wonder if you've sort of thought about how this kind of work can be expanded to understanding those natural processes that occur year after year in the Everglades.
It's actually funny you mentioned that, because recently, and by recently I mean 2 months ago, because I'm in Biscayne campus, I was at the Hole and Donut Reserve in the Homestead sect of the Everglades. Are you familiar?
Yes, the Brazilian pepper removal area. Yeah.
Yeah, it was a very terrible operation for someone threw all these for those who don't know, threw all these peppercorn field seeds onto a field, and they grew. And now the area is leveled. They leveled it. These sinkholes in this area during the dry season, I went there and I observed personally mosquito fish, the gambusia, top minnows, fundulus. We had some mollies there. And the water was so eutrophic. I was thinking, in the same context, maybe do fish excretions have the same impact on the nutrient levels in the water? I do feel like, this experiment sets a good basis for how fish nutrients flow, not only in a marine system, but in a subtropical, undergoing tropicalization region in freshwater in similar context.
Great. Thank you.
Thank you, Steve. Dr. Komanowski.
Oh, just a quick comment. You had mentioned at the beginning brook trout, and there's still some remnant populations of them in the mountains of the Southern Alps, but they're definitely small population. And kind of to Steve's point about composition of fishes and the role that they play in nutrient cycling, and what we've learned from these range compressions, and in environments like the Everglades where we're seeing some range expansions in terms of invasives. I think the context of your research could be really nicely applied and comparatively to other work. I'll have to talk to Justin. I know him and Will. Good work.
Thank you.
Any other questions, comments for Max?
I was just going to say that was a great presentation, Max, and I hope you will continue. And if you need help with your environmental group, let me know, because I can help you mentor your group through their advocacy. So
thank you, Rita.
Congratulations to our 2020-21 John Marshall Everglades interns. This collaboration with Florida International University has done wonders in moving our research, but also embracing some of the wonderful components of the John Marshall Everglades interns. And it's so awesome to see your passion. We're so excited about where you will go and who you will educate and who you will share all of your knowledge and experience with in our Everglades ecosystem with. I am going to hand it off to Nancy Marshall to present you with your certificates. You're on mute, Nancy. Wonderful.
Okay, here we go. Well, as a Marshall messenger, and that is exactly what so many of us are. But I just know from the spirit of John Marshall that he would just be praising the three of you today for the work that you are undertaking. It's just amazing. And I ask you to continue to engage the next generation of environmental leaders in the work that you're doing. And in closing, I would say that always remember for Everglades. Thank you.
Thank you for attending our celebration. I will be in person with our 3 interns as they present to a larger group of researchers and scientists at Florida International University. Thank you all who have attended. We will give it a second to ask any final questions or comments before we log out for today. And congratulations, Max, Catherine, and Michael.
Jennifer, this is Todd Crowell from FIU.
Hi.
I want to thank Nancy personally, you, Steve Davis. This is yet another, ongoing increase in our collaboration between the Everglades Foundation and FIU. Thank you very much.
Thank you, Todd.
Look forward to seeing you tomorrow, Jenny, at the Research Symposium.
We'll see you soon. And thank you again. We look forward to 2022. And we'll keep you updated on our next steps and our new interns for next year. Have an incredible rest of your week. Sarah.
Thank you. Thank you, everyone.
Thank you all. Bye.